Okay, so let's continue with the labs. And now we have reached a point. We have run a program, we have taken a C program, we have written an assembly language program, and then called it back to the main C program and did things. So basically, we have experimented with one C program where you do the summation of 1 to 9 and it works perfectly fine. But these are all simulations. The next part that we are going towards is how do you run the same C program on a RISC-V CPU. That's what is the whole agenda of this entire workshop, and that's what you are going to design in the next 3 days of your workshop. So the idea over here is we will have this RISC-V CPU, which is the one which we are going to do labs on, that is written in Verilog. But all of you will be doing the labs on transaction level Verilog, which is called TL Verilog. But for now, will for the labs, we'll take a RISC-V CPU which is written in Verilog. We will write a test bench. We'll have a small test bench already. It's already written, and we'll load the hex format file of the C program that we just saw of this entire C program. We'll convert this to a hex file and load it in the memory, and we will read the memory through the CPU over here, and the CPU will process the contents of the memory, and it will display the standard display that we are always looking, that some of the numbers from 1 to n. Okay, so this is the flow. There are some commands which converts. I'll show you those commands, and you can always run those commands on your own. So I'll show you the commands where how do you basically convert the C program to a hex file format, and how do you load that hex file inside the memory, and how that particular memory is being how this particular RISC-V CPU takes the content of the memory, or takes the hex file, runs it, and gives a display which is 1 to n. Okay, so let's look into that lab. It's pretty easy lab because everything is done. So just make sure you're in the home directory. Now type the command git clone https /github.com/kunalji123 /risk5 underscore workshop underscore collaterals.get. Okay, just make sure this is exactly the way, this command is exactly the way it is being typed in the same way, because if you don't type it in the same way, it might lead to something else. And press enter. So it will download some basic labs. Okay, if you now type cd is change directory, risk5 underscore workshop underscore collaterals, and go to this particular directory, press enter. Now over here, if you type ls space minus ltr, you will see a list of files. There are some bunch of files which is present over here. We will go to the labs. So just type cd space labs. You enter into the labs and again do ls minus ltr. ls minus ltr is basically listing. Okay, so this is the file, and this is the RISC-V CPU, one of the RISC-V CPU, and this is the one. So if you open this RISC-V CPU, it's the top level module name, and you will see the entire. You will be able to see the entire Verilog netlist over here. This is something which we are going to design in the next 3 days of the workshop. I'll quit this one. So the way to open this is either through Vim, or you can use less. Okay, less is also good, and then press Q to quit. If you use Vim, then if you want to exit from Vim, press escape and colon Q. Okay, that will quit. Okay, this was the core. So this is the core which we are talking over here. This is the RISC-V CPU which is written in Verilog. Now let me show you the test bench for the entire thing. So it's testbench.v. So I will use Vim or less. Right now let me use Vim. You can also try it Vim. So this is a test bench. This is basically testing or verifying the entire thing, where PicoRV32 is a unit under test, UUT, and you give the initial conditions and things like that. So this is where you read the hex file into the memory. This is the command, and you might want to just take a look into this particular file. This is where we read the hex file. And now let me show you some standard scripts of how do you create the hex files. Also there is a size of the memory which is given over here. I'll escape colon q, and there is a script over here. It's called vim rv32 im.sh. You can either vim or less. And over here the set of scripts that is needed to convert it to the hex file and then load it in the picorv32 memory, and then run it. These are the certain steps or commands. So this is the C file which we are trying to load, and this is the load.s file, which has the assembly language program. Rest all are some commands. You might just want to go through these commands and look into what do they do, and you will be able to figure out the things that is happening over here. And finally, at the end of the script, we get hex files. Okay, we get these two hex files. Then we use a tool called as iverilog, and iverilog, it will dump out a file over here, which you see it's a VVP file. The inputs to the iverilog are the test bench.v and the core.v, and finally you basically simulate these activities which is present in the VVP file. Okay, so let's run this. We will escape colon q, which will quit the file. The next step that you have to, in order to run this one, the steps that is involved is chmod. First we'll change the permissions to 777 rv32 im.sh, then /rv32 im.sh, and this will basically run the entire thing. And at the output it basically says, I've just simulated for from 1 to 2, not a very small small number. You can also change it to, we can also change it to some bigger number, but right now let's not do that. We'll keep it 3, and we'll run the same program again. So it should give you sum of number from 1 to 3 is 6, sum of number from 1 to 2, it's 3. Okay, so this basically script, it creates the hex file. I'll just show you the hex file. It's a binary pattern, and this is what we had seen in the day 1 first or the second video, where we have explained the process of how does the application software gets converted to bit patterns or bit stream. Generally the terminology is bit stream, and this bit stream gets loaded into your this firmware, and the firmware 32. These are the ones, this is basically the bit streams. This is how the bit stream file looks like, and this is how it gets loaded into your memory through the test bench. This is how it basically gets loaded inside your memory, and it is being used by the picorv32 unit under test, UUT, and this hex file is processed by this particular core, and finally it displays the output in which is what we expect from the core to do. Okay, and that's it. That's what we are going to do. Is in the next 3 days of the workshop, this is what you are going to do. You are going to build this RISC-V CPU from scratch, and there are a couple of languages, high level languages to do so. In this case we are going to use transaction level Verilog, and from day 3, day 4, day 5, it's all how do you basically build this RISC-V CPU. And at the end of the day 3, we are going to run the same program, the same C program which we were looking into your own CPU which you have built, and we'll see if you get the same output or not. Okay, so stop the video, continue with the labs, and continue with day 3 of the workshop. Thank you.